Right triangles. We will start with Pythagorean theorem that describes the relation between the three sides of a right triangle. The theorem is named after the ancient Greek mathematician Pythagoras, but evidence suggests that the concept of Pythagorean theorem was used by other civilizations much earlier, such as Babylonians and Indians. So the Pythagorean theorem says, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the two shorter sides A and B. So we have the right triangle. Here is my right angle. Opposite the right angle is always the longest side, and that side is called the hypotenuse. So this side square is equal to the legs, the shorter sides A and B. Those sides can be the same, but does not need to be. We can have right triangle like this, and we can see that this side would be the always longest, and it's called hypotenuse, and this is one leg, and this is another leg. So the Pythagorean theorem is only working for the right triangles, and it says that the square of the hypotenuse is equal to the sum of the squares of the other two. So a square plus b square is equal to c square. Pythagorean theorem has numerous practical applications in various fields. One of them is in construction and architecture to ensure that corners are perfectly square, or to determine the height of the building that's perfectly square, that we can use the length as we have it in construction. So let's see example 1. A 15-foot ladder is leaning against a building. The base of the ladder is 4 feet away from the base of the building. How high up the building does the ladder reaches? So we have it. We have the building. And we have a ladder that is going right here. So the ladder is 15 foot long, and we have it that the ladder is leaning 4 feet away. So here is 4 feet away, and we are asking for how high it goes. So we are asking for this side right here. So let's call that side X. Here is the right angle. So opposite right angle is my hypotenuse, which is 15 feet. So we're going to have it that x square plus 4 square is equal to 15 feet square. And if we calculate all of that, we're going to have x square plus 16 is equal to 25. Then what we need to do is subtract 16. So we had that x square is equal to 209. And then we take the square root. So x is gonna be square root of 209. If you type this on calculator, you should get 14.4568, which is approximately 14.5 feet. So the ladder goes up to 14.5 feet. We round it to 1 decimal. To round to 1 decimal, we look at the next digit. It's 5 or more, so we increase that digit. Example 2. A television screen is measured by its diagonal length. If a TV screen is 48 inches long and has height of 27 inches, what is the diagonal size of the television? So the TV usually is measured in the diagonal. So we're looking for this diagonal. What is that side, right? we see that we have 48 inches. So let's do the diagram. We have 27 inches. Oh, I'm sorry. We have 48 inches long, 27 inches high, and we're asking what is the length of this one. Let's call the length C. By Pythagorean theorem, C squared is equal to 48 square plus 27 square. If we type this together on calculator, C squared, 48 squared is 2,304, plus 27 squared is 729. So C squared is equal to 3033. Take the square root, so C is square root of 3033, which approximately gives me 55.0726 and rounded to whole number 55. So the TV is 55 inches. In right triangle, we also use the trigonometry. Trigonometry is a branch of mathematics that studies relation between angles and sides of triangles. The word trigonometry itself comes from the Greek words. Trigon means triangle and metron means measure, trigonometry. So we have the trigonometric ratio. Now, we're gonna have right triangle, and we're gonna call the angle theta. To nicely write angle theta, we would use like O and with the kind of curly stuff. That's the writing of theta. It's a Greek letter for theta. So we have the theta right here. Regarding this theta, we look what is side opposite the theta. Side opposite the theta is right here. This is the side. Opposite here is my theta angle. What is the exactly opposite? This is called side opposite. Now, attached to the theta is my side. We're gonna call it adjacent. It's adjacent to the theta. And always opposite right angle, it's hypotenuse, and we will keep it as hypotenuse. Now, if we have the sides this way, then we can define sine is gonna be opposite side divided by the hypotenuse. That's the definition of sine theta. So sine is gonna be the length of the opposite divided by the hypotenuse. Then the cosine is defined as adjacent divided by the hypotenuse. So cosine of that angle, it's gonna be ratio of adjacent side divided by the hypotenuse. And tangent ratio would be opposite over adjacent. So tangent would be opposite side divided by adjacent. So in shortcut, we're gonna have that the sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we have an acronym that we're gonna associate them. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we're getting so, ka, to, wa. That means that the first three is for sine. Sine is opposite over hypotenuse, opposite over hypotenuse. The second two, three is for cosine. So cosine is adjacent over hypotenuse, cosine is adjacent over hypotenuse, and the last three is for tangent. Tangent is opposite over adjacent. Tangent is opposite over adjacent. And we're gonna use them in problems. Next example, find the missing quantities. So we need to find what is the x. So first we need to mark it regarding this angle. What we have, this side right regarding this angle, this side is straight, nothing but opposite to that angle, right? So we're gonna mark it that this is my opposite, so O for opposite. Then the side attached to that angle is gonna be adjacent, and the side that is opposite the right angle, the longer side, is hypotenuse. So now, what trigonometric ratio connects this side and this side? What trigonometric ratio connects opposite over adjacent? We would look back. Opposite over adjacent, tangent ratio. So we're gonna write tangent theta is opposite over adjacent. Now we will substitute what we have. So we have tangent, and the angle we have 24. So tangent 24 is equal, my opposite is x and adjacent is 42. We have x over 42. So in that case, tangent, type on calculator, tangent 24 degrees. So we use tangent button and be sure you are in degree mode. If you type tangent 24 degree, we should get 0.44552286. And this is equal to x over 42. So to solve it for x, we need to get rid of this 42. So we're gonna multiply times 42 times 42. If you multiply this out, we should get that the x, this 42 cancel, and we are left with the x equal to 18.69960, rounded up, so x is approximately 16.7. As before, to one decimal place. Look at the next one is 9. We need to increase this decimal by 1. We need to increase this decimal by 1. Part B, let's call this part A. Part B, as before, we need to identify the sides. So if we have an angle right here, opposite angle would be my opposite, right? So this is my opposite, this is my adjacent, and this is my hypotenuse. Opposite right angle is always hypotenuse, so the longest side is hypotenuse. And then regarding this angle, this side is adjacent. So now we're looking what trigonometric ratio uses adjacent and hypotenuse, because that's the two quantity we need to work with. So look at the definition, and we have that cosine theta is adjacent over hypotenuse. So we substitute cosine, my angle is 44. So we substitute 44. Adjacent side is 86. So we have 86 divided by the side C. Hypotenuse is C. So then we need to solve it. So first we would multiply times c. So the c cancel out. So we have c times cos 44 is equal to 86. We can type on calculator cosine 44 is 0.71933998, and this would be equal to 86. So to solve it for c, what we need to do, we need to divide by this 0.71933998, divide by 0.71933998. If you keep longer decimal, your answer would be more accurate. So normally we would keep couple decimal until last answer, at least 4. Try to keep it. So if we type this on calculator, we are getting that C is equal to 119.554068, which rounding together 119.55 or 119.6 if you want to round it up. Example 4, find the missing quantity. So we're gonna do exactly the same way. So we have regarding this angle, opposite would be opposite, and opposite the right angle is hypotenuse, so this is hypotenuse, and the side close to angle would be adjacent. So we have adjacent, opposite, and hypotenuse. Now we're looking for trigonometric ratio that associate my given sides, so this side and this side. So I'm looking trigonometric ratio that has opposite over hypotenuse. So if I use my acronym SOHCAHTOA, I'm looking which one has O and H as a ratio. O and H, so this is the sign. So we have sine theta is equal to opposite over hypotenuse. And then we substitute. So we will have sine. We don't have theta. We need to find it. My opposite is 12. My hypotenuse is 33. So we have 12 over 33. So sine theta, if we type on calculator 12 divided by 33, we getting 0.363636. So to find sine, we need to take, to find theta, we need to take sine inverse. So we're gonna have that my theta is gonna be equal to sine inverse of 0.363636. Sine inverse on calculator, we need to use either second function or the whole number. So right about the sine, you should see the button sine inverse. So then if you use the sine inverse of your answer, we are getting 21.3236 and so on. So theta is approximately to the whole degree. Usually we round it up. So 21 degree. Theta is my angle. Part B, let's call this part A. Let's call this part B. Part B, we start exactly the same way. So we need to do it. First, we need to label them. So opposite right angle is always the longest side, is called it hypotenuse, so that's very straightforward. And then with regard to the angle theta. Then with regard to the angle theta. Regarding angle theta, this is my opposite. So this would be my opposite. This would be my adjacent. So now I'm looking for trigonometric ratio that relates opposite and adjacent. So I look opposite adjacent, that would be tangent. So in that case, I'm using tangent theta. So we have tangent theta is equal to opposite over adjacent. So tangent theta is equal to opposite is 7, adjacent is 24. Opposite is 7, adjacent is 24. So then to solve it for theta, we would use the tangent inverse, of course, right? Tangent inverse of 7 divided by 24. You can type all of that on calculator. Make sure you use the second function for tangent inverse. So theta would be equal, I have this 16.2602. So rounding to approximate to whole degree, 16 degree is my angle. So this is my angle. This is my angle. We also have missing quantity c. We could use either trigonometric ratio, or because I have those two sides, I can use Pythagorean theorem. So using Pythagorean theorem, we have that c squared is gonna be equal 7 squared plus 24 squared. 7 squared is c squared is 49 plus 576, 24 squared. If I add that together, I'm getting 625. So c is square root of 625. So c is 25. Now we have application to word problems, and we need to know what is angle of elevation and angle of depression. So if you have straight horizon, horizontal line, going up is called angle of elevation, and going down would be angle of depression. So if you have So if we have one horizon, here is the observer, going up would be angle of elevation, so that would be angle of elevation, but then going down would be angle of depression. Right here is the angle of depression, right out of horizon. We have example 5. A security camera is mounted on a wall 7 feet above the floor. What angle of depression should be used if the camera is to be directed at an object located on the ground 10 feet from the wall? All right, so we have the wall and we have the floor. The wall, right above the wall, 7 feet, we have the security camera located there above the floor, and then the object is 10 feet away. So here is my object, let's call it a diamond. And we are asking the security camera what angle of depression. So angle of depression is not this angle. We need to have the angle with horizon, right? So angle of depression, we're gonna make the horizon straight. So this is my angle that I'm asking for. So this is my theta. So if I connect this right straight here, I'm getting a right triangle right here. This is my right triangle. And let's label what we have in that right triangle. This side is exactly the same as this side. So this side is equal to 7, and this side would be 10. Because this side is equal to this side and its side 10. So now we have, anytime you have angle involved, we need to use trigonometric ratios, sine, cosine, and tangent. So let's label them first. Let's label them first regarding this angle. Regarding this angle, this is my opposite that angle, so this wanna be call it opposite. And regarding this angle, this is my adjacent, so this gonna be called adjacent. And opposite right angle, the longest side is always hypotenuse, but not given. So we're looking what trigonometric ratio combines opposite and adjacent and opposite. So if I use my SOHCAHTOA, what trig ratio is using opposite and adjacent? Opposite and adjacent. Here is adjacent hypotenuse, opposite hypotenuse. So clearly my trig ratio is tangent. So we have tangent theta is equal to opposite over adjacent. So tangent theta is equal to 7 over 10. So tangent theta is 0.7 if you type this on calculator. So to find the theta, we take tangent inverse 0.7. And if we type this on calculator, we should get that theta is equal to 34.992, which gives me the angle of depression rounded to the whole angle, 35 degrees. So this is part A. For part B, this time we still have camera located 7 feet above the ground, and this time my object is 4 feet above the ground and 9 feet from the wall. So here is my 4 feet, here is my diamond, 4 feet and 9 feet from the wall. So we're still asking for angle of depression, so we're still asking for this angle theta. We're still asking for angle of depression, so we're still asking for this angle here, theta. And we can make right triangle right here. Here would be my right angle. Let's mark the sides, whatever sides we know. So this side is exactly the same as this. So that side is 9. Now we need to figure out what is this side. If the whole side is 7, and this side is 4, so we can see 7, my whole 7 minus 4 gives me 5. I'm sorry, 7 minus 4 is 3. So now we have the right triangle, and regarding the angles. So regarding this angle, this would be my opposite. So 3 is opposite, and 9 would be my adjacent. So we have opposite and adjacent. And we are looking what trigonometric ratio associate opposite and adjacent. So again, opposite and adjacent is tangent. So again, we're using tangent. It's opposite over adjacent. So tangent theta is equal to 3 over 9. 3 over 9 is 1/3 or 0.333. So to find theta, we will take tangent inverse of 3 over 9. And if we type this on calculator, we should get that theta is 18.4349. So theta is approximately 18 degree. This would be degree as well. So the security camera should be set up for angle of depression of 18 degrees. Example 6. A ramp is located to load a heavy object onto the track bed that is 3.5 feet high. If the angle of the ramp must be no more than 20 degrees for safety, what is the minimum length of the ramp that can be used? So here is our situation. We have a ramp. We have 3.5 and 20-degree angles. And here is my right angle. And I need to find how long is the ramp. So I need to find this side. So as before, we need to label them. We know that the opposite right angle and the longest side is always called hypotenuse. So this is my hypotenuse. Now opposite angle is called the opposite. So this side is gonna be called opposite. So we're looking for trigonometric ratio that relates opposite and hypotenuse. So let's use our SOHCAHTOA. And we're looking which side, which trigonometric ratio relates opposite and hypotenuse. Clearly we can see that this is the sine. So we're gonna use sine theta is opposite over hypotenuse. Sine theta is opposite over hypotenuse. So we substitute what we have. Sine, my theta, my angle is 20 degree, opposite is 3.5, and hypotenuse is my x. So now to solve it for x, we would need to multiply times x, multiply times x. This cancel out. So I have x times sine 20 is equal to 3.5. If we use calculator to type sine 20, we have that x times 0.34202 is equal to 3.5. And then we're gonna divide by 34202, divide by 0.34202, and in that case we are getting so then this part cancel out, and I'm gonna get that my x is equal to 10.2333. So my x is equal to 10.2 feet. So the ramp needs to be approximately 10. The ramp needs to be approximately 10 feet. Example 7. The angle of elevation from a point 55 feet away from the base of the building to the top of the building, the angle of elevation is 35 degrees. Find the height of the building. So we have the diagram right here, that the height of the building is here, the angle of elevation is from horizon up 35 degree, and 55 is my side. So I'm gonna just rewrite that this is 55. Here is my triangle, and the angle is 35 degrees right here. And we are looking for this x. So first we need to label the sides regarding this angle. This angle, this would be my opposite, and this would be my adjacent. So we have that this side is opposite and this side is adjacent. So looking for trigonometric ratio that associates opposite and adjacent. So if we use my SOHCAHTOA, what trigonometric ratio uses opposite and adjacent? Opposite and adjacent is tangent. So tangent theta is equal to opposite over adjacent. Substitute what we have. Tangent 35 degree is equal to, opposite is x, adjacent is 55. If we type this on calculator, tangent 35 is 0.700. This is x over 55. What I need to do is multiply times 55. Multiply times 55. This cancel out. So then we have that my x is equal to 38.5 feet. So the height of the building is 38.5. Example 8. Example 8. A submarine is on a mission and is diving at an angle of 15 degrees below the surface of the water. After traveling 600 meters along the descent path, how deep is the submarine? So submarine is going down and it's going at an angle with the horizon of 15 degrees. And we're asking how deep is my submarine. So we had the right triangle. Here's my right angle. We are asking for the side. This part we have 600 meters and the angle we have 15. So we need to label which side is given. So opposite right angle and the longest side in the right triangle is always the hypotenuse. So this is my hypotenuse. Then this side would be opposite the angle, so this side would be my opposite. And then we have angle. So we need to choose trigonometric ratio that relates opposite and hypotenuse. So SOHCAHTOA opposite and hypotenuse. Opposite hypotenuse is my sine. So sine theta is equal to opposite over hypotenuse. Now we substitute what we have given. Sine 15 degree is equal to x over 600 meters. We substitute. My theta is angle is given. Opposite, my opposite is x. My hypotenuse is 600. Now we can type this on calculator. So sine 15 degree is 0.2588 is equal to x over 600. So then we can multiply this times 600 times 600 This cancel out, and we have that my x is equal to 155.29 meters. The submarine is the depth of the submarine is 155 and 29.29.